Okay. All right. Okay. Let's do it. Okay. Well, thanks for all for coming to the OpenSIPS Summit. We'll start our presentation. This year, unfortunately, I couldn't travel for personal reasons, but I'm really glad. I have to thank Bogdan for being able to present using web conference. We have a presentation that I believe it's a bit fun. We have a lot of fun doing this on our office. I actually said to one of our interns that he should pay to do it because it was so fun that it's not a work. But let's talk about OpenSIPS and BIGDATA, how to integrate OpenSIPS with Elasticsearch. It's a really interesting thing to do. My name is Flávio Gonçalves. I'm the owner of the Office Group in Brazil. I'm also the CTO of SIPUS Technology. It's one of the companies on the group. And we have two new interesting things on OpenSIPS this year. It's the OpenSIPS new book. We have a new book on version 2. It took some time, lots of people involved, but it went through. And we have a new bootcamp. We have now a quick start in the website where it's a free training based on video, and the new bootcamp where we start from something more advanced. So we won't get bored with the basic stuff on the training. We are doing the bootcamp much more advanced than in the last years. So these are the new things this year on the OpenSIPS, the new things that I have been involved. Obviously, there are many things in OpenSIPS 3 and many really interesting, cool features on the new OpenSIPS. I have to thank Bogdan and Razvan, all the team, because you're doing a very, very good job. And we are seeing this when we are implementing OpenSIPS. We have always new features, very, very cool features that our customers require. Okay, next. What is SIPUS? Just to present the company, is a Brazilian company dedicated to VoIP applications. We have an anti-fraud system that we sell worldwide, and most of the other products, routing, billing, session border controllers, translators of CPI, CPT, media gateway controllers we sell usually in the local market. We have more than 50 small to medium telcos running SIPUS and OpenSIPS. Running OpenSIPS and running our billing routing system on top of OpenSIPS. Okay, let's move ahead. Before we start to talk about the solution, let's understand the problem. It's always hard to understand it's always easier when you understand the problem first. What the problems we were facing before searching this solution. Our master tool and the tech support was the terminal. So everybody's doing some terminal doing an SSH to all of the servers. We had logs from different sources. So we have an RTP proxy and a database in another machine and a proxy in another machine, and everybody doing SSH to all the places. And we have this syndrome that you probably already had on your own implementation, this comments in the wrong console syndrome. Have you seen that? A truncate in the wrong database? Yeah. Huh? A lot of time spent to get the information required to troubleshoot, and logs stored only for a few days. So that's the problems we were facing. Maybe all the tools we had, the master tool was SSH. Go to SSH, do a tail-f var log syslog or var log opensips.log. Go to every single server to grab the log. So this is the problem that we were facing. So the basic idea was, okay, can we put all our logs in a single place and make it searchable, easily searchable, and avoid these people doing SSH all the time? That's the basic idea of using Elasticsearch, is to centralize the logs and have an easy searching tool, right? So that's the problem we had. And then we discovered that we were generating a lot of data. What data? Our industry generates a lot of data. there are billions of CDRs, terabytes of traces, gigabytes of logs. This is not easy to capture, transmit, store, and search, right? Anyone doing capture knows exactly what I mean. It's not easy to transmit lots and lots of information. It's not easy to store. It's not easy to search this information. So we have big data on this industry because of the characteristic of this data. All of these wholesale provider generates. It's not unusual to have 1 billion CDRs in the database or in the logs. How can we make this data valuable? This is another thing. If we can centralize this data to a place where we can search, we can get some value. We can capture some value on this data. In the first place, the first thing that we want to do is to reduce the time to troubleshoot problems centralizing logs. 70% of the troubleshooting time is to collect data. And this is something that we have seen in our company. What happened? I started to do something interesting with the tech support. I was talking to the guys, okay, you can't scale any problem to me, but I need the log and the trace. If you can repeat the problem, reproduce the problem of the customer, grab the log and grab the trace, I can analyze the problem in usually no more than 15 minutes, right? But more than 70% of the time was collecting this data. Yeah, because, as you know, customers love to open tech support like this. Hey, I have a problem. And that's it. They don't send a lot of information. You have to call and discover what's happening in. The second thing we had is we want to enhance customer service, quickly solving billing issues. Mainly in the wholesale provider market and call centers, there's a lot of billing issues. Those 3 seconds, 3.1 second, 2.9 seconds, it's a big question for them because sometimes it gives a difference of $50,000 or more or less. So they want to know, hey, what's the exact time we receive the invite? What's the exact time we receive the buy? We need to quickly solve these billing issues. So shun is a major problem in unified communication and ITCs. The third objective is decrease cost to invalid or disconnected numbers. We grab an idea of, okay, if we can search the information of 404 and the reason 1 on ISDN when I have a number not found, I can start using this information to avoid calling. If I send a call to a number that I already know that does not exist, I can simply say, okay, do not call this number. We know that it does not exist. So if we can put this information from several platforms in a single place, place of data, if this information is easily searchable, we can decrease the cost invalid or disconnect the numbers. We can search numbers and IPs usage for fraud and block these numbers in real time. This is another thing we can do with big data. And this is the application that I will show. 20% of the numbers used in toll fraud are reused. We did a match between our database and the database from the CFCA, and we discovered that more than 25% of the numbers in the CFCA database were already in our database. So, and last, we can discover patterns with analytics and better server customers. We can discover patterns of use, who's sending 800 CPS per second. You have all the data, all the signaling in a single place. Okay, so we started to research, okay, what you're going to use for this. And we found on the internet many companies using this ELK. What is ELK? ELK is an Elasticsearch. Elasticsearch is a search engine based on Apache Lucene, right? You can search and analyze data on Elasticsearch. It's basically a Google. What we're doing here is more or less a Google of logs, right? So we are running our own search engine on the logs and CDRs and so on. The second piece of the puzzle, let me decrease a bit the volume. 1 second. Okay. Then it's a bit less perfect. Okay. The second piece of the puzzle is Logstash. What's the Logstash? Logstash processes any data from any source and contextualize this data and send it to the Elasticsearch. So Logstash is our tool to grab the information. And Kibana, however you pronounce, it's the way we explore and visualize the data. Right, so we started to use those three tools together, Elasticsearch, Logstash, and Kibana, integrated with OpenSIPS to centralize our logs. Okay. Oops. Case study. Before we start with a large number of data, I asked it for one of our interns, Mario. Let's start using ELK for anti-fraud information. We have honeypots in many places, and this honeypots generate a lot of data. Let's start using ELK for the anti-fraud information. We have some problems like number formatting. The hackers send the numbers in different ways. Sometimes it's hard to search the correct number. We wanted quick access to online information, so we wanted to store the numbers and in the same time search this number generated on the honeypots. We wanted to provide easy access to information, so right now there are concerns regarding the delivery of information using MySQL. So I don't want to give access to my database, but I can give external access to using HTTP to the search engine. And now we can use separate databases for online and offline. So we have a base of numbers that are offline. This information comes from different sources. And we have now an online source that you can have more false positives in the online information. But it's an option to use it or not. Okay, how do we create a honeypot? We use OpenSIPS 2.1, Apache, and distributed data centers. So we put honeypots all over the world. There's one honeypot in Virginia, Tokyo, Frankfurt, and Sao Paulo. And as there are many data centers available, many data centers where you can hold, we can insert on any database, and we change frequently the honeypots from one side and mainly from IP addresses. It's a very tiny machine, so the cost is a bit low. So the recipe, we use OpenSIPS 2.1, basically OpenSIPS 2.1 to do the honeypots. And in the middle here, we have the Elasticsearch. So now we have all these OpenSIPS servers using Logstash to generate information in the JSON format and publish it, doing posts to the Elasticsearch. You're going to see that we already improved the architecture a little bit, but that's the basic idea. Use the honeypots to provide anti-fraud information to Elasticsearch. Data flow diagram. So what happens? OpenSIPS generates the data to the syslog file, and we have the syslog sending this data to a file. Logstash reads this information from the syslog, contextualize this data, and send in JSON to the Elasticsearch. It's an HTTP post in the JSON format. The Elasticsearch indexes the data, and Kibana analyzes the data. At the end, what we have. Let's see. Sorry. Okay. What's the final? What's the final result? Let me open the Kibana, and then we can come back to dashboard. Okay. Let me load the save at the dashboard. This is the dashboard of the honeypot. So this is the final result after doing all this magic. We have a map with all the detections. We have the top 10 intruders, the top 10 destination numbers. So this is what Kibana is. So, okay, I went to the end. Let's go back to the presentation. I just wanted to show where we went from this place. Okay, so what you saw in the last picture was the Kibana, the analyzer. So we send the information to the Elasticsearch, and in Kibana we can visualize the data. Logstash logs data. So let's analyze now what we did with Logstash. Logstash receives the information from several sources. We can send the data for archiving, for monitoring, and from many other things. 200 available plugins, and no plugins for OpenSIPs, right? So we use this plugin called Grok. Grok is your friend. What Grok does is it parses arbitrary text and structures it. So this is what Grok is, right? So you put a filter, you create an expression like a match, and you can match your syslog. There's an application called the Grok constructor where you can check these matches. So you can match virtually any type of log on your system using Logstash. Let me go to the web, test Grok patterns. So this is how my log looks like. This is my log lines.
We can't see it.
And this is the pattern.
We can't see it.
That I have created to match this pattern. If I send go, it will.
Flavio.
You can see now all the information open here. ENI, intruder IP, SIP method, domain, honeypot IP, user agent, any domain, and so on. Right? So this is Logstash. Logstash is grabbing my log in any format and generating this information in JSON format as an HTTP post. Problems?
Yes. Yeah, we can hear you. Can you hear me now?
Yes, I can hear you.
Okay, so we can see the window you are presenting now. I think you have to share.
It's the browser.
I think it's probably sharing just the application.
Yeah, you have to. I think you have to.
I'm sorry.
Okay.
Perfect. Sorry. I'm using this tool for years, but they changed the interface just a little bit. Let me go back to the honeypot. So this is the dashboard. This is where we are going. Right?
Also,
this is the final solution after the. Do you see now?
Yeah, but please increase the font a bit, if you can.
Increase the font?
Yeah. Control plus.
Can you get rid of that box?
I think that
better?
might just be where his video was.
Yeah, it's better now. It's perfect now. Thanks.
Okay. So this is Kibana. So we have the map from the detections. We have the top intruders, the top destinations. This is the Kibana. Going back, we are talking about Grok. These are the Grok. This is the Grok pattern. So we have this log. This is the log generated from the common X log from OpenSIPs. Okay. And this is the pattern that we use to match these log lines. When you say go, it generates the data, parses it, and send this data using an HTTP post. Right? So this is the Logstash. This is how you can grab information from OpenSIPs and send to the Elasticsearch. Right? You have you will have the presentation. All of this information is there, so don't worry. Okay, back. After sending this information to the Elasticsearch, you can now search on the search engine. So I will access the Elasticsearch directly, not Kibana, the Elasticsearch itself. Okay. Let me, whoops. This is the dashboard, this is the Grok. No problem, I can save it for. This is the Elasticsearch. I have a password for this, so don't worry. I It's not open to the internet. So this is the first screen. And now I can do query results. So I will check for a specific IP address in the detections. Okay, they are here. I can use the pretty that shows this in a much pretty way. Right, so all the JSON requests that I'm doing to the search. So this is a search engine. There's a search language. You can search whatever you want in the Elasticsearch. And we can also look for numbers, for valid numbers. Right, and let me put in pretty. So I'm finding a detection here of a specific number, right? So this is what we can do using the Elasticsearch. So this is Elasticsearch. This is the Kibana. And you can do the same thing on Kibana too. You can do discover and find a specific number here. Let me. It's always easy to. Let me look for a number here. Okay. So I can see the numbers. I can see detections for register. And the funny thing, in the dashboards, you can also differentiate detections. I want to see detections based on register. The map will change accordingly. I want to see detections based on invite, and will change accordingly. Right? Interesting. Okay, so this is the Elasticsearch. That's the idea, is to contextualize. Searching, you can search for user agents, you can search for numbers, you can search for IP addresses using the Elasticsearch. Kibana Analytics, that's what we have shown you. Let me go back a little bit there. We still have time. Let me see. Okay. So this is Kibana. So if you want to create your own dashboard, you can go to Visualize and start creating area charts, data tables, line charts, whatever you want on the tile maps, pie charts. Once you grab one of these things, you can create this from a new search, from a saved search. After creating, you can add those things, those searches, to the dashboard to create this. And a nice and interesting thing here too, it is you can actually export this information. So if I go to www.tfps.com, the information from the honeypot was actually embedded in the website. Right? This is exactly the same information, but now I can export and embed in another site whatever information I want from the honeypot. Right? Interesting. Okay. OpenSIPS integration. So let's focus now on the implementation. Logstash is based on Java and a bit slow. And another problem with Logstash Java that I have to install a lot of things in the machine, on the server. And when installing many things, sometimes when the machine needs to be a little bigger. And I don't want it to expand a lot in the honeypots. We discovered that we can bypass Logstash, sending data straight from OpenSIPS, right? We want to also consume data directly from Elasticsearch. So the second step was, okay, let's bypass Logstash. We can contextualize data and send in JSON to the Elasticsearch directly from OpenSIPS. We don't need Logstash for this specific application. So we drop it Logstash, we drop it to Java, and we move it to do it directly from OpenSIPS. So we use the two modules from OpenSIPS here, JSON and the REST client. So if this method is invite, right, we set in the JSON body all the parameters here. So we contextualize the information directly on OpenSIPS. And then we did a REST post user password directly to the Elasticsearch, straight from the OpenSIPS server. So we don't need Logstash actually for this application. So we drop it Logstash and send it straight from OpenSIPS. So you can feed it Elasticsearch directly from OpenSIPS instead of using Logstash. In the same way, you can consume the information in the same way. You can use a REST GET. You can use asynchronous if you want. And put the HTTP user column password, the IP address, the port of Elasticsearch. I'm asking to count on a specific number here. And it returns 0. If the return is different than 0, if we have more than one body count, it exists. If don't, it does not exist. So I can go to the anti-fraud information directly in the Elasticsearch instead of going to a database. So I can publish the information on our honeypots directly to the public. If the user has a user and password, they can check this information directly there. Right? So that's another way to integrate OpenSIPS with Elasticsearch. So the first way was Logstash. The second way now is directly from OpenSIPS using a REST client. Good. What else? The second application that we started to develop is a quick billing log. For the quick billing log, we are using a RabbitMQ plugin. Let me explain this. What do we want? We want to solve billing issues quickly. So the problem that I have today with this billing issues, if I save all the traces, the whole base, it's a lot of data, and to keep it for a long time, it's a bit awful. So what we did, okay, what do we need to solve billing issues? The invite request, the invite reply, the buy request, the buy reply, and the data, the request time, the reply time, caller ID, callee ID, call ID, microseconds, and reply code. That's what we need. We don't need a lot more information than this to solve billing issues. But this time we have a different issue. That is, okay, let's do this using REST post. I already sent all the information for the prepaid using events, using RabbitMQ. So I'm already exporting the invite request, invite reply, all the events using RabbitMQ. So I don't want to send this information again using HTTP post. Okay, how do we store this on the Elasticsearch without doing it twice, without sending the events twice? There is also the possibility to use OpenSIPS to generate events. The RabbitMQ queue these events for prepaid, in my case. Now the Logstash can be connected directly to the RabbitMQ. It reads the queue, contextualized data, and sending JSON to the Elasticsearch. So in this case, I'm connecting Logstash not to OpenSIPS directly, but to the RabbitMQ. Then Logstash sends to Elasticsearch, then in Kibana, we can analyze data, we can search data for billing issues very quickly, and we can give this information to the user, to the end user. So that's the third way we had to integrate OpenSIPS with ALK. Advantages of using Elasticsearch. It's free and open source. It's quick, easy, and have power search capability. It's very easy to learn. There's a structured language to query that it's very easy. It's very easy to create an interface because it's HTTP from the beginning. You can send unstructured and correlated data. You can send logs. Logs can be one type of data, cdrs another type of data, and eventually traces. I know that Homer can export to Elasticsearch. So you can see, when you see one specific call, you can go there and see the log, the CDR, and the trace in the same place. You have a little bit more control over the size of the data set. If you don't want to send the whole trace, you can send only the information you want. If you're dealing only with billing issues, you're doing this only for billing issues, You can go there, okay, don't send everything, send only the information that I need. It's less costly to store in AWS if you're using a data center that charges per use. Sometimes it's better to send less data. It's less payment for network. You don't pay, and you pay less also for storage. So this is something that you should care to. And the easy analytics. You plug in Kibana on the Elasticsearch and you can do whatever you want in terms of analytics. You can generate graphics. You can generate lots of views of the information you already have. Okay, OpenSIPs in Elasticsearch. So you can integrate using syslog. You can integrate using REST client. You can do async calls in REST client. This have, how can I say, less effect in terms of server performance. And there are several use cases. Centralizing log, anti-fraud, do not call, blacklists. The imagination is the only limit for what you can do. Okay, scalability. That's the thing that we still don't have a final answer. For Elasticsearch, there's vertical scalability. You can put a more powerful hardware, and horizontal scalability. One of the good things about Elasticsearch is it's cluster ready, so you can cluster very easily. You can put lots of machines to receive your logs. It's ready for a cluster from the beginning. So to put 2, 3, 4 machines, it's very easy. You can also use data center servers like AWS Elasticsearch. You don't need even to install. Just create it and use it. As an example, I use the example of HChat, 1.2 billion messages using 8 Elasticsearch servers, 60 messages per second. 60 messages per second is a little bit low compared to what we have in many customers. There are people doing 500 calls per second. So we still don't know how much it will scale in very large operations. We're still in the beginning in this case. This is something that we need to determine. The good thing here is to know that we have horizontal scalability. What it is, you can put 8 servers, 10 servers, 12 servers to record all of your data. Further investigation. We are investigating also syslog-ng. It can be a good replacement for Logstash. Syslog-ng is developed in C and probably much faster than Logstash. Syslog-ng, it's capable to send data straight to Elasticsearch. We already use syslog-ng to send data to MySQL. So this log that I allow the customers to see on a daily basis is stored in memory, and we use syslog-ng to do it. It's a very nice piece of software and can be used to send data straight to the Elasticsearch, not using, you can bypass Logstash in this case too. Conclusion. Elasticsearch seems to be a viable platform for big data and to handle logs and CDRs. You can integrate OpenSIPs using REST client, RabbitMQ, or syslog in combination with Logstash. This is a preliminary research. We are not aware yet of scalability problems of the model. Horizontal scalability helps, but the cost-benefit has to be measured compared to SQL and no SQL approach. So I can't say to you right now, oh, Elasticsearch will be much easier, it will use a lot less hardware than MySQL, where you can store your logs and search too. So this is something that we still need to evolve. Okay, Q&A. I hope I haven't been so fast. I'm usually very fast too. Questions? Let me increase the volume. Too fast.
Anybody? Questions? Okay. Thank you, Flavio.
Thank you.